All right, our fourth and final kind of indeterminate form is going to be the indeterminate power. There are three different forms that the indeterminate power can come in. Those three indeterminate forms are 0 raised to the 0 power, infinity raised to the 0 power, and 1 raised to the infinity power. Now, with that in mind, our goal is going to be to attempt to get that exponent out of the exponent and bring it down front. So you may realize that that means that there will be a logarithm involved here. So what we'll do is we'll talk about this a little bit more generally and say that in general, an indeterminate power takes the form limit as x approaches a of f of x raised to the g of x power. So there is a multi-step process for how to evaluate this kind of limit. First thing is going to be to assume that the limit exists. We're going to assume that the limit exists, and we are going to give it a variable name. I refer to this as a dummy variable because we're going to introduce this variable, but then we're going to get rid of it by the end. So I guess maybe a catalyst variable would be good for my chemistry people. So we assume that the limit exists. We call it a name. If you would prefer to refer to it as some other name, that is totally fine. What we're going to do then is, because we now have an equation, we're going to apply a natural log to both sides. Take the natural log of both sides. So we take the natural log of both sides. Left-hand side becomes natural log of y. Right-hand side becomes the natural log of the limit as x approaches a of f of x raised to the g of x power. Now the idea is I want the natural log to apply to just this portion without the limit, which means that I will need to apply a limit law to move the limit to the outside. And that limit law comes from the definition of continuity. You can refer back to section 2.5 if you'd like to take a look at that particular limit law. So, limit comes to the outside, natural log goes on the inside. So we'll have the limit as x approaches a of the natural log of f of x raised to the g of x power. As soon as you have the natural log of a power, you can apply the power property to move that power down front as a coefficient. So this is called the power property for logarithms. Natural log of y is equal to the limit as x approaches a of g of x times the natural log of f of x. Now it is guaranteed that regardless of which one of these indeterminate powers you started with, you are guaranteed at this point to have an indeterminate product. Indeterminate product. This will take the form 0 times infinity. As such, we are going to force a fraction. And when we force a fraction, you have two options for how you can force that fraction. My advice is never move the natural log to the denominator. It's going to give you 1 over the natural log of something. And I'm going to say that's probably good advice like 99% of the time. There may be a 1% of the time where you don't do that. Now this is going to be an indeterminate quotient, which is what happens when you start with an indeterminate product and then force a fraction with it. Now eventually what that means is you're going to be applying L'Hopital's rule and eventually determining what the value of this limit is. So what we're going to do is skip forward a couple steps and say you've now evaluated this and it is equal to L. L is not your final answer. Rather, take a look at the left-hand side. This is what the natural log of y is equal to. The value of the limit is supposed to be y, so I need to finish solving this for y. Solve for y, which is either a conversion into exponential form, or we can simply say exponentiate both sides. So natural log of y equals L is equivalent to the statement y is equal to e raised to the L power. That is what you're going to see as your final answer. Expect to see lots of final answers that take the form e raised to a power as you're working on these problems. We'll do a couple examples in the next video.